The topic is basically if we have collected data and we have this data with us and we want to use this data in a different environment. For example, what Dan presented in the morning, what the master student is doing, and we have identified that actually we cannot match the data perfectly. What can we do? So that is basically the basis of my topic. So if there are different data, and when you have this data, the main part you are looking at is analysis and modeling, and you want to use it for decision making. But always there are certain issues when the data doesn't perfectly match, and it comes from the relationship between the different parts which make up the data. And the parts which make up the data is basically the features. And the features are formed from the objects. So that's why you get the word objects. So when you are able to handle the objects which form the feature and the feature which forms the data, then you are able to collect the data. And because when data is matched, then we find almost everyone will need data from different sources, and we have been seeing this in almost all the presentations. And this data comes from different sources, collected by different methods, and you store it differently. Then when you go to the issue, when you have this data and you start now doing direct matching, most of the time it will result in some little mismatch which can create an opening between the data sets or an overlap between the different data sets. And that leads to unwanted pass-in within the data set. So what did to explain it properly, which is the geometrical adjustment problem, if we have, assuming we have two layers, we have the cadastral layer and we have the load layer, collected by different companies at different times using different methods. And we want these two data sets to be related or might be used for decision making. And I want us to focus on this section where we have, for example, plot 35 and plot 37, and see the corresponding section on the road. And the whole basis to bring up. And when you match those two data sets directly, most times the way you saw it, it will cause either an opening. You can see that on 35 and on 37, the plots are a bit longer, but on the road layer, it is not indicated. And when you go to this, and that's why we have that overlap. And when that overlap happens, we need to eliminate it. We can't eliminate it directly. There are several approaches which have taken place, which you can use actually to eliminate that, or certain suggestions. One of the suggestions would be actually, let us use the standards available. And if we collect the data using the same standards at the same time, then maybe that will not happen. But that is always not the case. You can't actually use the same standards all the time, because different agencies have different mandates. Maybe the road formation unit or UNRWA will use different land, Department of Land will use different standards. So you can't say mine or yours. Because of that, then there will be always that difference. Then at what level should we use the standard? Is it in storage? Is it in data collection? And that is also a big question. Then what about the geodata already captured? Do we need to eliminate it and don't use it? Then what about the different applications? It requires different integration. So there are different researches which have taken place, actually how to overcome the geometrical integration issues, which is basically, and within those researches, most of the time when normal GIS practitioners get the data, you are always tempted, because these algorithms exist. For example, one which can do the cleaning of your data set, and you are tempted actually to run them. But sometimes these algorithms should not be applied at that level. Because when you apply them, they will move unwanted overlaps and also throw away the small objects which are unwanted at any point. But at the end of the day, you don't achieve perfect matching. Like the example I showed you at the beginning. And the main reason actually when I did literature review and I looked at different areas, it is always the level at which we integrate the data. We integrate it as a layer, or we integrate it as a complete feature, or we integrate it And at feature level, it may not be the whole feature which, for example, I've captured this building. It may not be the whole building that has an error. So when I find the error in this building related to another, and I apply it to the whole building, one corner which is right may actually be wrong. So what we decided to come up with an approach where we just pick the exact section or point which we can actually apply the collection, and the whole basis is basically to develop a geometrical object-based algorithm which can handle a point or just a line or a section. And to put this into perspective, I just picked a layer of the districts of Uganda and I focused on one district. All of us know how to pick that using an GIS application. But when we look at that shape and we go back and we look at the data structure, you'll realize that behind there we have within the attributes behind, we have the geometry, we have the extent of the polygon, we have the vectors which give us the x coordinates, the y coordinates, and we have the rest of the attributes. So when we are developing the algorithm, the focus was not actually on the last two lines or rows which handles the attributes. The focus was actually on the second, the third, and the fourth. Where is it located? How can we manipulate this? We took advantage of the way actually GIS data is stored, because you can actually manipulate each of the parts of the GIS database using the coordinates. So we took that, and so we extracted the vectors for the x and y, and which define the end polygon, and through that we developed our algorithm flow chart. And from the algorithm flow chart, we start with comparing the data sets. Are they polygons? Do they have polylines? Or are they composed of only points? And from there, we can identify the different objects which make up that data set. And I have said the objects are the ones which form the features, then the features form the data sets. Then we go and we adjust the different sites. If it is longer, we adjust and everything. But understand this flow chart better. I extracted just some part of a data set actually, and I just zoomed in into a section. If you look on the extreme left, upper left, you realize there is a figure or an object which is AO. When you compare it with the figure on the right, so it should be exactly the same as other. So when you merge these, sometimes we may create an overlap between that, but you can see the same data set. It is only one object, and it is only one object which has an. So when we develop standard algorithm and we apply it to the whole data set, it will even adjust others, but others have no issues. So extracting those two, I got actually A0, then we have R. So you can compare them, and when I compare further, you realize that it is only needed to move only a few verses from one corner to another. So that was basically the basis of developing the algorithm, where we compare the polylines forming that figure, then we adjust the length, and sometimes you find the vertices making up that polyline are not the same, so we introduce more polylines so that at the end, before applying the final adjustment, we have the similar number of polylines so that we have corresponding values. Then we can correspond. After corresponding the two figures, then we are able, the algorithm to run, where it finds only the difference, where it adjusts, leaving the rest of the polygons in it, or the objects within the data set unaffected. And we developed this algorithm actually using MATLAB. It is available, and it is a very high-level object-oriented language which you can implement this. And we tested it using QGIS, and we developed some scripts actually using Python to make sure we can be able to test what we wanted, and to make sure what we developed is able to work. We tested it on the Ugandan data set. We picked the Ugandan data set of 2006, which had 81 districts, and we picked the Ugandan data set of 2010, which have 112 districts, and we tried to see whether it can work in that condition. Then we tested it also on some data set which had only small, and the different testing situations. So we tested on adjustments where we had the adjustment data set having less vertices compared to the reference data set, and also we compared, and at the end of the day you realize that we got the result equaling to the reference data set. Then we looked at only considering the polylines. Then also we adjusted the data sets which were in different locations to see whether actually the logarithm can move it and adjust the polygons accordingly to move everything in a new location. And also we tried out that this algorithm on different areas where we have only the points, we have only the lines and the polygons. The results we got from that, we realized that when the adjustment data set, we want to adjust actually has more vertices and has more objects or features, it will always be increased in relation to the reference data set, because always you need a reference here. Then in all situations, most of the polylines actually within data set will always be adjusted and they will be equal to the reference polyline the way you wanted to reference it. And when we had the final location of the data set actually moved to the writing position when we applied the logarithm. Then one of the key things actually we incorporated in the logarithm, and at the end when we tested, we learned that it maintains the attributes and the topology at the end of the day after running the logarithm, which is very, very important in analysis and in modeling. And when we further zoomed into the different data sets, we ran the logarithm that only the needed objects which needed, or polygons or polylines or points which needed to be moved actually were moved, and it responded to the way we wanted, which was the reference data sets. Just to summarize the advantages of the logarithm, you don't need to actually handle everything in the data set. You just need to, the logarithm uses points as the final adjustment, because we know in our GIS we are able to store the x and y, which is basically a point. Although that point is on a polyline or on a polygon, it is still a point, and it is what defines actually the polyline. And so that's one advantage of working, and because of that, we are able to translate in the process of running the logarithm. We are able to move all these into text format, and we reduce on the process time or burden on the machine, and it adjusts using, converts it in the text format, and all the adjustment is done using, and then later we create the graphics the way it is needed in the GIS. And the rest just in to conclude the application, and this algorithm can be actually applied in the geometry and alignment, and there were different presentations actually within this conference where people wanted to adjust and align different data sets, and it can help actually in spatial analysis and modeling. Then also the algorithm is able to get the geometry values from one object, compare it with another object, and use it to collect any specific object within the data set. And when we developed some scripts in Python, this is what we want to do to wind up this one. We want actually to compile these scripts together, and we come up with sort of like a small plug which we can use in QGIS, and can be readily available to people who want. Thank you.
Thank you very much. We started the presentation. It's not necessary, I think you have some substitutes there. Now, when you say it is an algorithm, and we are today in 2015, and the presentation you've seen here, we have any softwares which are already doing this. And if these softwares are already doing what you are presenting, do they have an algorithm behind them? And if so, is this different from them? And in what way? Then also, can this application find use the problems we are seeing in the DCP, in the areas in Uganda now?
Maybe. Anyway, the chairperson gave opportunity to one, but I was expecting more questions. And then for the I left out that, but actually when we were doing the research and everything, we looked at it, the possible available softwares from the most common ones to open source and everything. And we tested actually to accomplish what we wanted to do. And that was the basis to come up with actually this algorithm, because we wanted actually, the initial part we wanted only to align two data sets to do something else. Then we got the actual, we can, when we align objects overlap, and when we apply the existing algorithm developed by different researchers, they wouldn't actually have a specific corner of one object in there. And that's where we ended up and suggesting to develop a new algorithm. Yes, in existing software, we have several algorithms. For example, if you pick QGIS, it has very many algorithms inside there. And each algorithm accomplishing a certain task. And what we actually developed here is not something which can replace a big application like QGIS, no. It is something which can only accomplish a small function. It is not sort of like a full software to use. It only, you apply it in one of the existing software for you to help you only handle that adjustment of the shapes. And not the whole layer, but only a specific shape on that layer.
If we use the
yes, can it be used? I will say yes or no, because I haven't tested. Something you haven't tested, you cannot say it can be used. So, if we can identify that actually the issue, because I was actually hearing to the previous presenter talking about the georeferencing part, when actually the issue is to be with georeferencing, then the algorithm is not fitted to do such a work. After georeferencing, and you have these polygons, and you realize that when you georeference and you identify a certain area, for example, we were talking about Mukono, Wakiso, and you realize that only a few of the polygons inside there, or the land parcels in this case, need to be adjusted. Then you pick what you think. Actually, having two data sets. What I think it will be the second data set which he said was accurate. Yes, when you have that very accurate data set, then you use that as a referencing data set. Then you can say that this is what I trust. So run using this data set in all the rest, or in this other data set, and identify all those polygons which don't match with this, and then change them. But you cannot actually, if it was not geo, for example, if you have the accurate data set, and those polygons are not existing there, you cannot actually use this algorithm to create them in the other, because they are not there. It only works on already existing, but not properly placed where it is, or the shape slightly varying, but you have to refer to it, you have to refer to a known shape. Then it will apply to this other shape. Thank you.
Thank you to the State on the Wall, Dr. Moses Musinguzi.